We are going to be creating, as you can see on screen, a procedural eyeball model and material. We're going to be rendering it with Eevee, setting it up for real-time viewport shading, complete with refraction in the eye. And the process actually was not that hard. The shader, I don't think, is that complex. Model is definitely not that complex. And I think the result ends up looking pretty good. So let's get started then. We are going to begin with a brand new fresh Blender scene. I'm going to delete everything in the scene, select everything, hit X to delete, and then we're going to hit Shift A to add a UV sphere. This is going to be the basis of our eye. And right away, I'm going to rotate it 90 degrees. So I'm tabbed into edit mode with everything selected RX90. The reason is with a UV sphere, you've got the way it's constructed is you've got two geometry poles at the ends. That's where all these lines come and converge into what's called a triangle fan. And this is going to create some problems for the shading. Potentially it creates problems. I'm kind of keeping my fingers crossed that we don't notice it once we get to the end. But what is good about the UV sphere is that we have these concentric edge loops that can be easily manipulated into being the iris bulge, the corneal bulge. So speaking of the corneal bulge, let me quickly jump over to my browser and let's just refresh what our eye anatomy is like in our heads. So let's just look up human eye. Take a look at a diagram like this one I like. So the eye anatomy, it's not actually a round ball. It's organic, so it's round-ish, and we're gonna go with the ball shape, but it's not perfectly round, and especially the cornea bulge right here is not round. It literally bulges out, which is where the iris is at. So we're going to want to create this in the geometry, and we'll do that very simply. But that's kind of as far as deep as we're getting into the outside shape of the eye. We are going to then create another disc inside that serves as the iris. And this structure will work really well to create the recognizable refraction inside the cornea. So I want to just take a mental snapshot of this eye structure and the size of the iris. All right, so I'm not going to like bring this image into Blender and get it right. It is just a diagram, so I'm going to eyeball it, pun intended, and then we will create that bulge. I'm going to go into my side view, go to wireframe, and it looks like this section about matches what we just saw on that diagram. So I'm going to select those verts, hit SY to scale in the Y-axis, and that's going to create our bulge, and I can just move it forward to continue that smooth line into, that smooth contour into the cornea. And that's really all it should take. We can shade smooth and then control like 3 to make it as smooth as we can, or make it very smooth. And that should be pretty good, honestly. That's all we really need to do for modeling. This is the shading artifact we've been talking about. If we move it to matte cap and something like the car paint shader, it gets very, very bad shading artifacts. It's not that noticeable in the eye, but let's go ahead and fix it just to say we did our best. Maybe move this above the grid floor. A lot of you know that that is a pet peeve of mine. So let's fix it. I'm going to create a new UV sphere and hit Control 4, which adds a subsurf modifier at 4 levels, making it extremely smooth. And I'm going to scale this down and position it to align to the contour that we have in our cornea. All right, so I'm going to scale it up, make it fit as close as possible, and you'll see why. All right, so that is close. And remember, this is a perfect sphere. We just created it, and the pole is on the top, as it usually is by default. So this means that the side is like optimal smooth sphere geometry. So with that created, well, it's just called Sphere 01. Let's call the original sphere I. And with that created, I can tab into the original sphere and delete that middle vertex, and then grid fill. Oh, so Control F. I never used that hotkey. That's good to know. Grid fill right there in Control F. Usually what I do is hit space and type in grid. And that will fix it perfectly. As long as it's got an even number of vertices, it's going to fill that in with quadded geometry. And I'm going to rotate it. Let me look from the front view. I like to rotate these so that we have, if possible, we have a horizontal line continuing all the way across and a vertical line, which you can see here. Once I've created that, I'm going to hit, let's see, vertex smooth vertices, and do that a couple times with Shift R. Then I will use my snapping to snap to the face and project individual elements, make sure that's turned on, and I can hit G and then left click to end the operation, and that's going to smoothly snap those verts right onto that secondary smooth sphere. All right, so I can even scale this, and it's still, no, actually I need to enable the scale option. Now when I scale, it will continue to snap to the surface. All right, let's hide the sphere 01, and let's see if that solves it. It really didn't, did it? Vertex, smooth vertices. And I mean, let's see. Oh, maybe what I need to do is turn off subsurf first. Okay, yeah, I think that was my problem. I put the secondary sphere in line with the smooth version of the eye geometry, and I needed to put that on the unsmooth version. I needed to align it to the unsmoothed version. Whoops. All right, so when I moved that, you saw that it snapped to the surface and went really wonky. All right, let's try this again. All right, snap from the front view. Here we go. Okay, so yeah, that's gonna be, I think, the smoothest we can get it. And granted, it's not perfect. So that's part of the frustration with this, with spherical geometry, is you're never gonna get it perfect. It's going to be imperfect to some degree. So if you can, while this is less of a shading artifact, if you look close, you can still see the leftover square corners from the grid fill that we did leaves those corners, and it's less noticeable, but it is still noticeable. I mean, now I'm getting into the weeds. This is kind of why I wanted to avoid this, because it ends up being like taking more time than you ever want it to. What I did there was just simply use Alt-S to just push it in slightly. Sometimes pushing it in slightly can take care of some of that. Anyway, it was never meant to be that complex when it came to the eye shape, but we are going to call that finished. It looks pretty good. It's definitely going to suffice for this model. The next thing we need to do is duplicate a circle that will serve as our iris. So I'm going to, let's see here, probably Control R to select, to create a new edge loop right here. Shift D with snapping turned off. We're going to scale it down slightly. E, S, G, Y, E, S, G, Y, and then E, Alt M at center. And then scale everything to make it a deeper dome. All right, that's going to serve as our iris shape. And we don't need that edge loop that we cut. It's just going to unnecessarily make that section of the sphere rigid. So Control X to remove that. And then we're left with our smooth iris, our smooth sclera and cornea, with the iris as a separate piece of geometry. Now we're done. Let's save the file. I'll call this record, REC_01. All right, let's go to, we're done with the model, so we can switch to our shading tab. We're not gonna use any texture maps. We're gonna go all procedural. So we're gonna remove that browser window. Also, to do this, by the way, if you don't know, you hover your cursor over any corner of any Blender window and you'll see the crosshair pop up, and you can click and then drag to merge windows. All right, so we don't need the UV editor. We don't need the file browser. We're going to create a new material, and we're going to call this sclera and underscore cornea. All right, so if we look back at our anatomy, the cornea is the dome, the clear dome that sits in front of the iris. And the sclera is the white portion, the eye whites, and then the iris and the pupil. Those are really the only four parts we're going to be mindful of as we model this and shade it. All right, so we've got the sclera cornea, which is going to be combined into one shader. I'm also going to select the interior iris, Control I to select that. Invert, if you select the exterior, invert it, and that's how you get that selection. In the material section, we will add a new material slot, a new material, and call this iris. Now, right away, I'm going to change this color to be like a bluish, just a generic blue. We'll come back and make that proper. But I want it to be blue so that when we make the cornea transparent, we'll see right away the difference. So we're gonna go back to material preview. I don't like to personally see the background so much, so I'm gonna turn that off and also turn off the look dev preview. Keep in mind when you have two materials on the same object, you might, it can be confusing to which one you're editing, and you have to be mindful of the slots that you are currently have active. So we're gonna work on the sclera first, and so I wanna make sure slot 1 is selected. So the first thing I wanna do with the material is isolate the portion of the eye that's going to reveal the iris, so the cornea essentially. And we're gonna do this with a gradient texture. So I'm gonna hit Shift-A to add a texture, gradient texture. And then I have the node wrangler tool enabled, so Control-T with that selected will add a texture coordinate and mapping node, which is exactly what we need. Shift-Control clicking on that, also a node wrangler tool, will plug whatever I Shift-Control clicked on and show its raw data in the viewport. All right, so by default, the gradient texture has a left to right gradient across the sphere, but we don't want the linear type, we want the spherical type. This will create a sphere of texture data in 3D space, and wherever it intersects with your object, that's how you're going to see it projected onto your model. Now, we don't want to use the generated texture coordinates, we want to use the object coordinates. The reason being, if I enable our object origin, the object type of texture coordinate is dependent, like the origin of that texture coordinate is the orange dot, the origin of the object. So I know it's at the center, and that just helps me navigate my way through this mapping node a little easier. Also, it works fine whenever you're rotating the object around, as long as you're not deforming the mesh. So we've got the object coordinates going into the gradient, and I know that there's a white sphere in the middle of a white texture sphere in the middle of this eye. And if I move it forward, you'll see that it starts to intersect a little more clearly. All right, and this is going to be perfect for us to add a converter color ramp, and we can dial in exactly where that cornea is going to end. All right, we want a nice smooth edge. Let's switch it to ease. All right, so maybe a little bit smaller than that. About like this. All right, so this creates a factor where the black will be the eye white and the white will be the transparency, the refraction. So with this factor created, I can plug this right into our transmission. Maybe I should make this a little bit bigger. The transmission socket of our principal BSDF. This will start to create refraction. So if I Shift Control click on that now, you should see that we have a white sclera and a transparent cornea. However, we need to change some things so that we can actually see the geometry behind it. By default, Eevee does not refract objects in the scene. You have to tell it to do that. It's more CPU intensive. Eevee's oriented towards real-time playback. So it like limits the amount of computer intensive things from the start. So the way we can turn that on, a couple places. Number one, in the settings, so also refractions are tied to screen space reflections. So enable screen space reflections, open the drop down, and you'll see refraction. So we will enable that. Still nothing happens because you also need to enable refraction in the material settings. So go to the material tab, under settings, change the screen space refraction to turn it on. And now it will get a recompile, and we should have seen that nuts. Screen space refraction. Why didn't that work? I think I know what I did. Not a bug. I think I'm just an idiot. I created the material slot and never applied it to the selection. Assign it to the selection. All right, now I'm going crazy. I did do that. Assign. Okay, all right. So actually, if you turn on screen space refraction for the material that's not a transmissive material, it will make it disappear. Okay. I'm sure I just probably confused the mess out of you. The problem being I did not assign this original iris material to the iris geometry. And so it was refracting twice, like both pieces of the mesh were refracting. I am sorry for that. I promise you, I went over that like 3 times thinking like it's a great reveal when you show it working the first time, but it's really confusing if you don't get it right the first time. And I didn't get it right the first time, so I apologize for that. But the point being, now we have a cornea that's being viewed, that's transmissive. We have refractions for the interior iris material. Right, so we've created this gradient section of the node network. I'm going to copy that, paste it into the iris material, and just manipulate it so it becomes the pupil. Right, so this I want to plug into, let's switch the flags around. We're going to create a nice little pupil. All right, so bring the flags really close. If you want more room to manipulate that, you can drag the color ramp out a bit. That'll give you more room to work with. Okay, now the white flag, let's go ahead and make it that blue color, very temporary blue color. Because at this point, we have a basic structure of the eye, complete with sclera, cornea, iris, and pupil. Pupil's probably a little bit big though. All right, now let's start polishing these off to be realistic and believable. So the sclera in the back is going to be like red, you know, bright red where the veins start, and then it's going to become a gradient into white or like a yellowish off-white. So let's, again, we can use the same structure we've already been working with, this gradient setup. And for this, I might just duplicate all 3 of these because I think I will need to move around the mapping node to get exactly what I want. So I'm just using the object coordinates. I'm going to hit Shift, right click, and drag to create a reroute node, just so it's clear that I am using only one texture coordinate. And then for this, let's Shift Control click on it so we can see the raw data. I'm going to switch to B-spline and then drag this out. Yeah, okay, so I thought that I might have to manipulate the mapping. I want to increase the size of the gradient sphere. And with the mapping point type, that means taking the value down. So 0.5, I'm going to move it backwards, or actually forwards. Okay, now we're getting more of the range that I want. So the black can become a dark but very rich red, darker but very rich red. Add another flag that's going to be a little bit towards the yellow orangish direction. And then finally white at the tip. Actually make that maybe a little more. No, that's fine. That's fine. All right, so this will be plugged into the color now. And we are going to be just a little bit closer to a realistic eye. Let's turn down the specular value to like 0.1. We want it to look wet, but don't want it to look overly wet. Next, we need to add the veins. We're going to do that with a Voronoi texture. So Shift A, texture, Voronoi. And we're going to also use the object coordinates. So let's just plug that in from this reroute node. And I'm trying to do a better job keeping my node networks like cleaner and more understandable. So we're going to pull that out there. And also I need a mapping node. So vector mapping. You kind of, when you do this stuff a lot, you just kind of realize like, I know I'm going to be manipulating these texture coordinates. So let's go ahead and add it. And then, you know, start playing with it, kind of preemptively adding the nodes that you use all the time. So with the Voronoi texture, let's look at that by itself. I'm going to add a converter color ramp, change it to B-spline, and drag up the black flag. All right, once we do that, we can, it doesn't really look like veins, but hopefully you can see that veins are going to come out of this type of pattern. So by dragging the black flag up, we get these really fine, spindly interconnection of Voronoi edges, basically. All right, and that's going to work really good for the vein pattern. But first, what I want to do, I'm going to change the type to normal. And I'm going to scale in, I believe, the y-axis. Yeah. So I admittedly don't know exactly why this works. It's just something I figured out while I was playing with it. But whenever you switch to normal and scale in Y, it kind of sucks it down into the tip of the sphere where the cornea is. So this works perfectly for stretching out this pattern to be more veiny. And then the last step is to add a noise material, a noise texture node to kind of wonkify this pattern, to kind of make it wobbly is how I usually think of it. And I'll show you what I mean. So texture, you see me do this a lot if you've watched me do shading tutorials at all. We're gonna add a noise texture and a color mix node. We can actually mix a noise texture into the texture coordinates themselves using the color socket. And I'll also use object coordinates for this as well. Hopefully that's readable. All right, so we're going to change the mix to be linear light, and I'm gonna make the value really low. Let's just turn it off to begin with. And now if I drag it up, you'll start to see that all our lines, become wobbly, become broken up with a noise pattern. And from here, we're starting to get into the vein territory. Let me make the scale a little bit less. So if you go up, it's going to look very serrated is maybe the word I'm looking for. So the higher scale value you go, you get this serrated type pattern, whereas the lower you go, you get a more curvy pattern. So if we increase that, hopefully you can see kind of what I mean. But we have all the ingredients to get what we want out of these veins at this point. And to incorporate them into the color, I'm going to add a color mix RGB node. And we're going to use this vein black and white pattern that we just created as a factor in that mix. And then we're going to copy the dark red color, hover over it, Control C, and then Control V when we hover over color 2. Change the operation to overlay, Shift Control click, and we should take a pretty big leap into realism when it comes to this vein pattern. What I like about overlay is that, we have the red being incorporated pretty believably, but as the color gradient switches to that slight yellow coloration, the veins also change into that orangish type color. And I find that to be very believable and effective to look like the veins and the sclera, the white of the sclera, are interconnected, right? If it's just a mix, this is a small detail, but I find that it's not as connected, I guess. And so I like to use overlay here. I just really like that slight color differentiation. And it looks to me like we need more veins, a higher frequency of veins. So the Voronoi scale, let's make that higher, like 10. That works pretty well. We can also adjust the, we have all kinds of things to adjust to get exactly what we want. Like the color ramp here, we can change that. All right, so if we want a more bloodshot effect, or we want it to be a little more realistic. And keep in mind, whenever we overlay on white, they're going to, the effect is going to diminish. So if we make the white more distinct, we're going to lose the veins entirely. And so that's just something to be aware of. We do want the veins to diminish as it gets closer to the cornea. And so at this point, let's see what it looks like in the final material. All right, so yeah, the veins are actually reaching into the cornea, definitely not what we want. So let's just bring that white value down more like this. There we go. Maybe the veins are a little too plentiful as well. So we went from 5 to 10, let's go to 7.5. Not too bad. All right. Veins are included. What else do we have to do on the sclera? Oh, we can use the vein pattern as a bump map. Of course. So there are, like, the veins on your eye do protrude out ever so slightly from the surface. So if you look really close at your eye, I don't even have my reference loaded. What a goober. Right, so we are going to, okay, right. This black and white is going to be perfect for using as a bump map. The white will appear to protrude out and the black will stay down. So we are going to add a vector bump node. Take the color of our color ramp, plug it into the height. And I know that the strength of 1 is going to be way too much. So let's go to 0.1. Shift Control click on this and we'll get a rainbowy type data set for the normal bump data. But you can see that there is a protrusion effect. Now, I want to modify this because it's a little too sand dune-like. So I am going to add a color RGB curves node. And I'm going to make an S curve, let's let it compile. What I'm doing with this node is basically bottoming out the darks and the lights. All right, so by this S curve, I'm bottoming them out on both ends, and we're gonna get a more believable kind of vein effect. All right, so that should work pretty well. Let's plug this into our normal. Let's see what that looks like. Okay, so ignore the cornea because now it looks like some sort of weird gemstone, but the actual veins do have a very nice pattern to them. Like you can see them, the reflections are playing off them like they are an actual vein, cylindrical vein shape. I think it's still too strong of an effect, so let's go down to 0.05 just to make that a little more subtle. This is one of the realistic things I missed for a long time when it came to an eye, is that I would just create a sphere. It would be perfectly glass-like and reflective, and it didn't look real because the surface of the eye actually has undulation from the veins. So that is a very important effect. However, once we get to the cornea, as you can see in the reference, it smooths very much. I can only imagine that if the surface was like this on the cornea, our vision would be significantly blurred. So I need to use the same gradient effect right here to eliminate the bump effect from the cornea. So I think what I can do is just duplicate. This is the only if I duplicate this, Shift-Control-D and move it down, I've got this very confusing line going down the entire node network, but hopefully that's not too confusing. But before we get to the bump node, I want to change this gradient to essentially invert it. So let's switch the flags around. All right, and I'm going to Shift-A color mix RGB node. This is going to be a multiply at 100% so that the black is multiplied over the data of our veins. And so now we should see the veins kind of stop once we get to the cornea. And then I could also kind of taper it. If we go to B-spline, I think that'll look pretty good. So we can see now that our cornea is very, very clean. There's no bumpiness going on. The veins end believably before we get to the cornea. All right, so the sclera and cornea are now finished. We can jump over to the iris, but before I go there, we're going to create this pattern in the iris, we're going to just simply copy the Voronoi nonsense that we did here. We're going to copy it. Remember that we're using object coordinates, and we're going to paste this into the iris material. Grab the object coordinates, make a reroute node, and then pull it down. All right, so we're going to use all of these, but just manipulate them to be more what we want. So if we go back to the Voronoi after it's been in the color ramp, we should be able to just scale this value up even more. First, let's mute the linear light where we had the noise kind of doing its thing. All right, so now we can scale this up, and as it pulls to the center, we start to get a very believable pattern that looks like an iris. So yeah, you can see that. I hope you can see that we only use a few components, right? Like the gradient along the sphere, and we're using the Voronoi texture, as it's manipulated according to noise, scaling it down the normal y-axis. And yeah, it's pretty easy. There's simple building blocks to create a fairly complex material. So yeah, we've scaled that down. We have that iris shape. Let's re-enable the linear light, and we want it to be a higher noise value. Let's go to 5 and way lower factor. We don't want it to be messed up that much. All right, so now as we start to squiggle these lines, that's actually looking really good. All right, so let's take that and incorporate it into our original gradient up here that created the colors. We can do that with a color mix RGB node and overlay. Let's mix that together, see what it looks like. Okay, so the blue, yeah, when you overlaying a saturated color typically increases the saturation and the value. So it takes this already overly saturated blue and makes it like super stylized. Very not believable. So this is a great opportunity, since we've got this color ramp, to imitate the coloration in this gradient. We're going to need another flag. Let's just color pick. Let's start by color picking. It starts as a dark color, and then it turns to a very light desaturated blue. And I'm sure this image has been photoshopped. I mean, I feel like eyes that particular color are not common, but so you can see color picking that did not really give us the desired result. So maybe we'll make that brighter manually, take it up in value, down in saturation, like 0.15 maybe. The darkness, let's bring that up. And actually, there's kind of a little hint of orange in there. I mean, we can definitely do that. Whoops, I switched to, what did I do here? Let's switch to B-spline. All right, so with B-spline, if I want this black to be really sharp, I simply need to drag another black flag up to meet it. All right, and you'll see that that eventually connects. But I don't want a super crisp, razor sharp line at the pupil. You can see that there is a little bit of a fuzziness to it. All right, and then I wanted to add another flag in here that kind of goes into the yellowy spectrum, just ever so slightly. Anyway, I think this is a little bit more believable. Very cool. All right, so that's looking pretty believable, I think. One thing you can do is, in the picture, you can see that the pattern, the gradient pattern, is wobbly as well. I keep saying wobbly. I hope you guys know what I mean. So that means anytime you hear wobbly, we're going to add a noise texture and a linear light mix. So we will Shift-D, duplicate these nodes, and we'll do that to the gradient. All right, so we're going to take the object coordinates, linear light, this noise texture. Let's plug that in. You can see that if we slowly crank up the value of the linear light, it gets more and more wobbly. All right, this is great, except it also makes the pupil wobbly. So similar effect to the cornea whenever we eliminated the bump map from the cornea, we can do that same sort of thing. Let's just duplicate these nodes, Shift-Control-D. We will reset them, or reset the mapping. No. Let me hold up. Reset the color ramp by hitting the backspace key. And also we will use object coordinates here. Need to make a little more room for this. Right, so what I need is to eliminate the pupil. All right, so we will do this kind of thing. Let's make it an ease type. All right, so black, whenever we plug this into the factor of the linear light, black is going to have no effect, so no wobbliness, and white is going to have full effect. Well, we don't want full effect. Remember, that value is really, really low, so let's take that down significantly. All right, and let's play with that, see what it gives us. All right, okay, this is actually pretty good. So you can see as I manipulate this color value, we have no wobbliness on the outside, a lot of wobbliness on the outside, and almost none in the pupil. So this actually worked out really good. All right, so that's good for the colors, in my opinion. The last thing we need to do is incorporate the bump map. Let's see what that looks like. We should be able to use it just as is. Let's look at the raw bump map data. It looks like it's not shade smooth. Okay, now it is. Yeah, I think that looks good. I want it to be a little stronger, so let's go to 0.1 instead of 0.05. Drag that into the normal socket. All right, so that looks pretty good, but we have a problem. The normals are showing up inside the pupil. So this kind of brings up the point that I don't like specular for the iris. I like to turn specular off and turn metallic on. Okay, because metallic, I don't really know why, but it respects the fact that the pupil is black and it doesn't reflect. Whereas specular will reflect over top of the black. And so also you get this really kind of, I feel like eyes shimmer, you know? And so that also makes sense to me to use the metallic, but we really get a vibrant effect when we turn on the metallic. We are going to save that scene. Whenever you want to incorporate this into a model, because again, like, well, maybe I haven't said this already, but I'm not making eyeballs just to have eyeballs. Like I always want to put these in characters. So if I save the scene, Control C to copy it, I'm going to open the Ecorche model that I built. Maximum, set quality, material preview. All right, so let's, I copied the eyes from the other scene, so we can simply remove this one. Control V. There's our new eye once it compiles correctly. Jake, now that you mentioned cycles, would this material show up well in the cycles render? Oh, it should. Let me turn on cycles and see if it does for sure or not. All right, so we're going to move this into position. Just going to eyeball. It's the second time I've used that pun. That one was unintentional. There we go. That looks fairly believable. It can be tricky to position the eye. There we go. All right, so the difference, notice the difference between these two eyes. The brown eye looks like it's more integrated into the head. It looks more believable, whereas the right eye seems to be glowing. And this drove me crazy when I first stumbled into it. And the reason is, sorry, that wasn't positioned quite perfectly. The reason is something about screen space reflections negates ambient occlusion. So if we look at, let's see here, screen space reflections. This is important. Again, all this is important if you want to incorporate this eyeball into a character. Let's go back to shading, our shading tab, look at the rendered version and mess around with the material a bit. So yeah, if we add an ambient occlusion node, input ambient occlusion, it is enabled, you can see in the render settings. Shift Control clicking on ambient occlusion should show ambient occlusion appear. I'm on the iris, hold on. Not what I meant to do. Go to the sclera, add an input ambient occlusion. What we should see here is a darkening at the contact points. And if we turn off screen space reflection, it appears. You can see the darkening now. So whatever it is about screen space reflections, which you need to have on in order to get refraction in the material, it eliminates the ambient occlusion. So it always feels like your eyes are kind of glowing. So we need to fix that. And I think I messed up the iris a little bit. Yeah, I disconnected it. And I want to show you how you can quickly fix it. It's kind of a silly fix, but we're going to use this same color ramp, Shift Control D. All right, so let's click on this. What we want to do is create that ambient occlusion from a gradient by ourselves. Since this happens to be an almond shape, we can get pretty close with a fake ambient occlusion. All right, and so if we scale out in X, scale down in Z, you'll start to see that we can, whoops, not that one. Oh. If we change it to B-spline, you can see that we can create the ambient occlusion manually. And this is this is the only way I've figured out to get it to work nice with Eevee. So let me move that into position a little bit better. There we go. That reads like ambient occlusion a bit. To incorporate it, Shift A, shader, mix shader, Shift A, shader, diffuse BSDF. And the diffuse BSDF is going to be pure black. It needs to go in slot number 1 since the ambient occlusion is black. So that will be slot number 1. And then slot number 2 gets the rest of the eye. And that should look like the eye is set more in the actual lids. It all comes down to the ambient occlusion. There we go. Now that I see it in context, this is also where you could adjust the colors, like maybe the white, it's a little too white. So like, let's bring up the other almond color, the like tan type color, bring up the red a little bit. You know, you can change the veins around, but really I think I need to adjust the color here. I don't want the ambient occlusion to be too dark. But anyway, yeah, all this is just to show you how to incorporate it better into a model. And if we want to make the eyes brown, we can simply do that with a hue saturation node, color, hue saturation. And I know somebody, I think Mikhail, you didn't like blue eyes, so we can switch that to like a brown. Let it compile. Darken the value. Anyway, there's the hue actually leaves some purple, so it might be a better idea for brown. Let me mute that and instead add color RGB curves. All right, so if we take the green and blue values down, green, blue, and take the color down. There we go. That's more of a brown. Okay, so that's going to be it. That's the eye. That's about everything I know about creating a procedural eye. Yeah, any last minute questions? Let me hear them. Okay, so